Let me show the problem then. Oh. All right, so here's the problem that we're about to act out in the class. You guys on the video can't see us, but if anybody's even watching it. Yeah, we can leave that there. Okay, so I'm Mr. Gill, you're Contreras. We'll call you Daniel. We'll change it to Daniel and I can rest. So 1 second goes by. How far do you run? You run how? We'll just say the number. 8, right? So let's say that's 8. We obviously don't have 100 yards, so we'll say that. So you're a little ahead of me, right? I'm a little behind. Now, in the next second, you still run 8, right? So you'd go your 8. I only go 6. So now I'm even farther behind you, right? You'd be 16, because he went 8 and then 8. I only go 6 and 6. So I'm losing ground to him, right? He's pulling away from me, or I'm losing ground. He's getting farther and farther in front of me. So we would keep doing that, and clearly he's going to win because he's going to continue to get even farther from me. Now in the second one, though, it gets a little tricky. Because of what? You're still faster than me. Nothing changes. You're still going at the same. But where are you starting? If this is the starting line.
Back there.
You back there, right? Where am I starting? I'm back here. So again, we'll say this is about 20. So now when 1 second goes by, you go your 8, but I go 6. So you shortened the distance. I was 20 yards ahead of you. How far am I ahead of him now? After 1 second. 6. No, I went 6. So where am I at? I started at what? I started at 20 and I went 6. So I'm at 26. Where is he at? He's only at 8 because he started at 0 and went 8. But if you take the difference, 26 subtract 8, he's only 18 yards behind me now, not the 20 that he started behind. So again, I go 6, he goes 8. What just happened? Where am I at? I'm at 26, now I'm at, well, I was at 26, now I'm at what? 32, right? I went 6 more. Where's he at? 16, because he went 8 and 8. So if we subtract that, 24 and what was it, 18? 16. Yeah. So he's gained 2 more yards on it. Well, so I'm at 32, and you're, oh yeah, 32, that's it, 34. I think I said 32. I'm at 32. He's at 18, so if you subtract that, he's only 16 yards. So he's catching up with him. That's the principle. The question is, does he have enough, because we're only going to 100 yards and then we're done. Does he have enough room, basically, to catch me before we hit that finish line? That's true. Fantastic. So here's how you, so again, normally you would create an equation, you'd set the equations equal. That's how they want you, that's the math lesson. I'm telling you right now, you don't always have to do it the math way to figure out the answer on an EOC. And this is what the EOC is all about sometimes. You're not going to remember everything you did in math, but you can figure it out if you think about what's going on. So let's kind of draw it out. So again, we'll say D for Daniel, G for Mr. Gill. So we start off. Oh, actually, what did I do wrong? If this is the start line, 0, what do I need to change? Why? What do I have to do? That's right. What do I need to do with that G? Yeah, I need to, if I'm representing where we're at, I'm ahead. I got a head start in that second scenario. So I'm actually up here at about 20 yards. We'll say that's the 20-yard mark. And what time are we at right now? We're in those spots. What's the time frame? Damani, what's the time frame if that's where we start? Are you in a good mood today, Damani? No. I don't like it. What's the time frame at 0? If you're at 0 and I'm at 20. Well, that's the distance. 20 is the distance I'm at. 0 is the distance he's at. So what's time frame? Nobody guess. Big guess. 0. Yeah, 0. No time's gone by, right? We're at the starting line. The gun hasn't gone off. So the time right now is 0. So at 0, so I'm going to do in black. Actually, yeah. So I'm at 0. He's at 0. I'll put it below each of us. So 1 second goes by. Where's he at? Well, just say the number, because it's not going to be drawn to scale, so we're going to have to write numbers in. Well, 1 second goes by, because that was 0. 8, right? In 1 second, he goes to 8. Where am I at? So I was at 20. So I'm at 26. So that's after 1 second. So it'll get a little confusing, but I'll explain it to you. So 2 seconds goes by. So he goes to 16, right? Where am I at? I'm gonna have to start writing really small in a second. So we'll just do the next one. What's the next one? For him. Oh, it is 24. For me. Yeah, 6 to mine. So do you see what's happening? His distance here, he was 20 behind when we started, 0 seconds. He was 20 behind me. Now, though, at 3 seconds, that's not a very good 3. So we're at 3 seconds. That's what the black is. I'll rewrite it in black. At 3 seconds, he's only 14 behind me. He's catching up. So I'm going to just kind of finish writing all of them out quickly. So if I go 8 for him, he's at 32, 40, 48, 56, 64, 72, 80, and we want him to get to the finish line so we can see who wins. So 96, 104. So that gets him all the way to the finish line. The question is, does he get there? And it takes him 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So somewhere between 12 and 13 seconds. Actually, right in the middle would be 12 and a half. So he gets there at 12 and a half seconds. That's how long it takes him to get to the finish line. So if I get there before 12 and a half, I won. If I get there after 12 and a half, he won, because he was already there at 12 and a half. So that's kind of like what we got to figure out now. So again, I just do the same thing for my distances. So my next one would be 38 plus 6 would be 44. And then plus another 6 would be 50. And then 56. And 62. And then 68. Oh, that's not a very good 6. And then we would do 74, 80, 86, 92, 98. I kind of ran out of, oh, this might work. Yeah, that's enough. And then 104. All right, how many seconds did it take me? Count them. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it takes me over 13 seconds to finally get to 100 yards. So who won? Yeah, he gets there. So again, 100 yards would be right in here. He gets there between 12 and 13. So a little after 12, 12 and a half exactly. So at 12 and a half seconds, I'm still right here. Like this would be 12.5 right here. So I'm at like 95 yards. So he would be at 100 when I'm at 95. So again, there's a lot of different ways to actually determine who won. You could say, like I did, who gets to 100 yards first. You could do it more based on the time. The point is, that should give you an idea. Even if you can't create an equation, any of that stuff, you can't graph it, you can write some information down on some of these problems. They're word problems, if they're just asking you to solve them, that will help you figure it out. So don't give up on word problems. Try to figure out what's going on. They do, not always, but they do try to make them something that's fairly realistic, that you could imagine what's going on. I'm not gonna, in other lessons when I've done this in the past, I've graphed it out and done all of that. I'm not gonna worry about that today. We might come back to it on Wednesday. So now we're gonna create an equation. again, this is designed for an EOC right here and how to try to pass the EOC, as well as it'll be on your exit ticket. But mostly you're gonna have to solve it on the exit ticket. Something really close to that. You're gonna have to kind of know how to go through the process and come up with the correct answer. All right, so, oh, didn't mean to do that. Let's create an equation for Mr. Gill and for Contreras. I'm sorry, we'll do Contreras since it says that. All right, so let's create the equations. Here's the only thing, I want you to get the whole thing, but here's the main thing you need to come out of with this. What's going to go into the equation for Contreras? Without a doubt, no doubt about it, this is going in there. What is it? 8, right? I mean, 8 belongs to Contreras. We'll figure out what to do with the 100 and other stuff, because the other stuff's a little tougher, I'm not gonna lie. The 8, it belongs to Contreras. Like, there's no doubt about it. I guarantee you, on an EOC, at least one of the options for Contreras' equation is gonna have a 6 in it. You better be able to eliminate that option. You better say, well, wait a minute. I know the 6 stands for the speed. I know Contreras wasn't running at 6. That was Mr. Gill. So his speed is 8. I know I can eliminate that one that has the 6 in it. Even if it's in a different spot than where we're going to put all of this stuff. Even if it's in a different spot, it is still not Contreras' information. So if you can eliminate answers, that's how you're going to pass the EOC. I mean, that's going to be your biggest obstacle to graduating is the EOC. Guaranteed. I mean, I see it right now in juniors and seniors. They've got the credits, they've got the GPA, they've done ELP, credit recovery, whatever they needed to get all of that stuff. We can sort of control that at this school. We can get you the credits. You may not like it because, you know, you may have to do summer school or extra classes after school or that kind of stuff, but we'll get you the credits. We can't help you out on passing one of those tests. You have to do that. So you've got to know how to figure stuff like this out. And if you can just eliminate answers, normally the EOC passing, or I'm sorry, the passing score, it's not like a 70%, it's like a 40%. You don't have to be perfect on it. You just have to be able to do a good job of eliminating possible answers that you know don't make sense. And then from there, you just make your best guess. What needs to be in mind then if 8 isn't his? What would go in Mr. Gill's equation? For sure, no doubt about it. 6, right? 6 is my number. I own that number. So now if you have those two equations created, I would be shocked if you can't eliminate at least one answer and possibly, maybe even 2 answers. If they give you 2 different equations, here's where it gets a little trickier. What else do we need in an equation? And this will be in there, you won't really have to guess about this. But we need variables, right? We need x's and y's. So we're going to need a y and an x somewhere. What would, any guesses as to where the x and y would be? If I tell you x stands for the number of seconds and y stands for the total distance, any idea where you'd put those? What do we say a total normally means? And where would that typically go in an equation? We have a total. Yeah, it's all by itself, right? Remember that. Don't forget. So we're going to have the same variable for that. It's just going to be his distance versus my distance. But y is typically a total. Now, sometimes you're going to have to figure out, is it like in the different format where x and y are on the same side together? And this one, I'm just kind of telling you this is the way it is. So x would be the number that we would multiply. It's the number of seconds. So if I want to know how far I've gone and I run 8 yards per second, then I multiply 8 times the number of seconds. So if I've gone 1 second, I've gone 8 yards. If I've gone 2, I've gone 16. 3, I've gone 24. So that's why the 8 goes there. And it's very possible that they give you the equations and they ask you questions about them. Like they may just give you the equations and you may have to determine what x and y stand for. So the answers may say y stands for distance, x stands for number of seconds. So, and I may do that on Friday also. Here's the trickiest part. So in this second scenario, ignore the first scenario. Second scenario. There's something that changed that means we have to change one of those equations. One of them's actually done. What is it we need to change? Which equation and what do we need to do? There's some information we got in that second part. We got to include. Well, that's how far we're going. So that's actually a solution for y. If we were going 100 yards, we would plug 100 yards in for y. That's actually what a y value would be. And then we could solve for x to figure out x. So what else is in the second part that we got to take into account?
For a second.
Well, we've already taken that into account with these. These are the yards per second. So Jeremy just said, I think, there's that 20-yard head start thing. What do we do with that? So let's think about it again. At 0 seconds, where are we?
0.
But not in the second scenario, where are we? At 0 seconds. Daniel is at 0, but where am I? I'm at 20. So if this is my equation and I said at 0 seconds right here, right now, if I said with this equation I'm at 20, that wouldn't work out, because if I plugged in 0 there, I'd be at 0. So that equation's not right if I get a head start. What do I need to do? Willow, what do you think? Because 0 doesn't work. If x is the number of seconds, and this is the distance, well, if I plug in 0, it's saying I'm still at 0, but I'm not. At 0, where am I? The second scenario. I'm at 20, right? So what do we need to do to that second equation? We add 20, that's it. Because at 0 seconds, this equation should work out to be 20 yards. That's where I am. So that's like your y-intercept, basically. If you were to graph it, that would be your y-intercept, and then you would show a line that represents how far I've gone from there. His is plus 0, because he really is starting at the, remember we said that y-intercept is like an initial value. It's a starting value, it's an initial value. Well, that's the initial value. He's at 0, I'm at 20. We'll go into more detail on that one. So those are the two equations. If we really wanted to solve it out and figure out exactly when he catches me, not at 100 yards where we would be, but when he catches me, we would say, okay, when would the distances be equal? So that's an example of those substitution problems where we took this part of the equation and we plugged it in for y and made them equal. That would be the distance that where he catches me, where we're at the same distance from the starting line. I'm not going to have you do that on the, I might do it for a bonus question or something else to get, but the point where he catches me is where our distance is equal. So we just set that equal to that, and then we solve it out. Should come out to be, I think, well, when does he catch me? We said he catches me, so he's at 96 at 12 seconds. Where's our number the same? So at 9 seconds, he's still behind me. At 10 seconds, he catches me. Because if you look at the 10-second mark, so at 10 seconds, right, we've both been running for 10 seconds. I'm at 80, he's at 80. So visually, you already know the answer is 80. And if we plug it in, we should get 10 seconds, which we do. Because 20 divided by 2 would be 10. All right, so any questions on that? You'll see that on Friday. I'm not changing that a whole lot. That's going to be, now I might ask you an additional question about it, kind of like what I was just going over at what's this number of seconds or something like that that he catches me at. But I would say, hey, who's going to win? Explain your answer, and then I might ask one more question. But again, you don't have to create the equations for this type of problem. The next one is all about creating equations. If you did not get a packet, we're going to use packet now. If you did not get a packet, come up and grab a packet. Everybody got one? Go quickly because you need to see how to do this equation that I'm about to do. You didn't get packet? Packet?
Yeah.
Yeah, just right there. Can you get it real short? Yeah, actually, that's not stapled. Is that one
This is
stapled?
really big.
Is that number one?
This
Just make sure see how the first page didn't staple on this one. Just make sure the top page says number 1.
This is a book.
It is a book. You gotta have this done by the end of spring break.
This is homework.
Homework for spring break, yeah.
You're lying. Good. So if it was spring break, I'm not gonna lie to you, I would have done it.
Yeah, I'm lying. Well, this is what we're gonna go over this week, and then I'm gonna pick a couple for your exit ticket on Friday. But it'll be ones we've gone over, so it won't be anything super new. We won't get through most of this packet, but. All right, so here's what you need to know. Look at number 1. I am giving you the absolute easiest, most basic, these are still system of equations because there's going to be 2 equations based on 1 word problem. And this is also really more preparation for your EOC. You'll do this again next year, but I'm introducing it to you because these are the kind of questions you will see on your EOC. These are the word problems. It tells you that you have 2 numbers, or it says find 2 numbers. No. Actually, I'll be honest, I don't remember, but we're gonna go with. I think they got to use it on the elimination one, but not on the substitution. And that's substitution. All right, so on the first problem, it says find 2 numbers. It says their sum is 12, their difference is 4, right?
Yes.
So we're going to go over a few notes, and this is for, like I said, this is pretty standard stuff for word problems. How do we know what our variables stand for? Like if we are asked, like sometimes they'll just give you the equation. They'll say, here are the equations for this system of equations. And then they'll ask you questions about it. They'll say, what does X stand for? What does Y stand for? How do we know what they stand for?
One side line.
No, that would be the solutions. The lines are the solutions. What's a variable? What do we say the definition of a variable is? Way back in the beginning of class. What's a variable? It's what? It's a letter, and that letter stands for what? Well, we're using the letter because what? What is a variable? JD, what's a variable? Take a guess.
Symbol.
It could even just be a symbol, not even a letter, right? Why do we use a symbol? Why would we write a symbol instead of a number? What? We don't know the number. The variable is what you don't know. Here's your first note. I mean, you should know that, but if you didn't remember that, you better write that down. The question is asking you to do something. That's what the variable is going to stand for. It's whatever you're trying to solve for because you're solving for the unknown. So if it's asking you, now technically there's not a question in that first one. It says find 2 numbers, so it's telling you to do something. But it's the same thing as saying what are 2 numbers. So again, it's the unknown. So what's unknown in that problem? What do we not know in that first problem? We don't know the 2 numbers. By value, it means what are the 2 numbers? It just means what are the 2 numbers. So we don't know the 2 numbers, so those are our variables. So we could, and it doesn't tell us any information really about one variable needs to be like X or Y, like the biggest, doesn't say the biggest number has to be X or the smallest. So we would just say that's the first number, and then that's the second number. That's all we got to say. Or if they ask you a question, not yet. You need to see this. This is what you're seeing on Friday for your exam. Definitely this one, and then probably a couple more. So that's all you have to understand. If they ask you, what are the, most likely they wouldn't really ask you. They'd want you to create the equations in these because first number, second number is a little too easy for them to ask you questions about. So what do we know about those 2 numbers? What's it tell you? Imani, wake up. are right on the borderline. Like sleepy puppy. Puppy that's falling asleep. What do we know about the two numbers? Just read the question. Well, so what do we know? Just read it. Literally just read it. The difference is 4. What does difference mean? Mathematically, what does difference mean?
Difference between the numbers.
Which mathematically is what math operation?
Division times subtraction.
You're just throwing out some stuff.
I have to.
Well, then I'll let you know that Willow gave us the answer. Difference means subtraction. So you need to know that. Difference is subtraction. So we know that if we take the two numbers and we subtract them, they're 4. What else do we know? You gotta go read the rest of it.
12.
So what does sum mean? No. Sum means addition. Just means if you take the two numbers, so you can go, that's the answer. I'm going to solve it out, so when you get back, I'll catch you up on it. Sum means add. It technically means it's the answer to an addition. The sum is the answer to an addition problem. Difference is the answer to a subtraction problem, which just means you're going to subtract the two. That's it. That's your two equations right there. Done. I ask you to create the equation, which is what I will ask you. I won't ask you to solve, not this one. This one's too easy to solve. I might give you a little tougher one. How would you solve this? If that's the two equations and you wanted to solve for x and y, how would you solve that? Alex, how would I solve that? If these are my two equations, I created them, and I want to solve now and figure out what are the two numbers actually. Look at it, because we just did it last week and the week before. What about those two equations and the way that I've written them is the specific part. What do you notice about the way I've written them? What do you mean by that? Say it again. Yeah, what about where they are? We got x's and y's, but what's important about where they are in that? 12 is over a 4, right? A number is over a number. What else is over each other? Equals over the equals. What else? Isn't x over x, y over y, equal over equal, 4 over 12? How do we solve that? Once we got to an equation or a system of equations where we say everything was nice and organized, how do we solve that? Remember what it's called? You had graphing, substitution, and elimination. Which one was this? Elimination, right? We said if it's all nice and organized, we can use elimination. What did we need to solve in elimination before we started just adding straight down? What did we need? Two things. Opposite signs and what? Same number, right? Do we have that? We have opposite sign and same number in this. We actually do. We don't see any numbers, but if there's no numbers, we have ones, so we have the same number. And we have opposite. No, we don't have that in front of the x, but we said it just needs to be in front of one of the two variables. Opposite sign, same number, we're good to go. We're already ready to solve this. We just add straight down. And we should see that something disappears. And it does. Negative 1y plus 1y. So there I get 2x. Well, to solve it, I just basically divide by 2. So that's one of my numbers. How do I get the other number? How do I get the other number? Kira, how do I get the other number? Got it? Yeah, just pick an equation. Say it. This is the same thing we just did. We are doing what really is the beginning part of solving systems. So everything we did to solve comes from some type of real world problem where in real world, these would be called constraints. So like if you have a business system, you have resources and constraints. Actually, I guess it could be resources and constraints, either one. And you have to follow those two rules. There's no way around it. Have to follow the two rules. So you got to figure out, well, what are my possible answers within, how do I say it? The word is confines, but that's probably not a word you've heard a lot. Basically, I have to follow the two rules. How do I get my answer? Like how many units I want to make or something, if that's what I'm trying to figure out. How do I determine how many units I want or how much I charge per unit based on the two limitations that I have? That's what a system of equations does. So you guys always ask, when do I need to use this stuff? It's used all the time. Algebra, I just used it when I graded tests this weekend. I wanted to know how much to set the point values for questions. So I created an equation and said, okay, well, if I want this problem to be twice as much as this one, but the total amount has to be, I think I made it 35 points. How many points should each question be? So again, if you know how to use it a little bit, you'll use it all the time. I'm going to pick the top equation. Doesn't really matter which one. X subtract y equals 4. So I plug in 8 for x. So 8 subtract y equals 4. So what is y? You don't even really have to finish solving it out using two equations. Yeah, 8 subtract 4 is 4, right? So y is 4. So I mean, there is a way I would subtract 8. Well, if that's a negative y, I got to divide, negative 1y. You could even say divide by negative 1, divide by negative 1. But you can probably just tell 8 subtract 4 is 4. So y is 4. So those are your two numbers. If you add them together, they're 12. If you subtract them, they're 4. So that's a pretty simple equation. Everybody should be able to create that equation. I expect you to be able to do that on Friday, but more importantly, that's the kind of thing you need to be able to do on the exiting. Go ahead and do number 2. Should have no issues whatsoever doing number 2. Literally the same thing. And the one on the exit ticket will be pretty much the same thing as these. By the way, I didn't write this in the other class. Should have. If you ever see product of two numbers, product means multiply. So difference is subtract, sum is add, product is multiply. Very rarely would you get anything with division. If it said, it would just say the quotient is, which quotient just means division. Still on it, huh? You put it lower at least to try to hide it better, but not very well. You're still not. Nadia is a little better at it. She's had more practice on that. Still going at it, huh? Yeah, that's a really important one. All right, so I'll give you a couple minutes. You should have if you can do that one, that's a pretty good start for Friday. Again, the first one that we did, the Contreras one, I'm going to give you one like that. You'll have to solve that one out. So you won't really have to create the equation on it. If you can, and that's the way you want to solve it, that'd be pretty fast one. And then on Wednesday, tomorrow for you guys, we'll go over some of the other ones in the packet. I don't know how many we'll get to, we'll see. But I'm telling you right now, you have to be at least okay at word problems if you want to pass an EOC. Thank you. Well, actually, this goes. Where are all of the other exit tickets and quizzes? Interesting. Nope, not in there. Courtney, you are all caught up, I believe now. Oh no, you have the big ones. What am I thinking? Are you guys all on your phones? Come up. So you just did the. So yeah, you still have that big one, which is the one worth most points. Hmm? You're lost. Well, you don't. So okay, so that's an important thing. You are not solving an equation when you're creating an equation. Too many people try to come up with what the answer. The answer means nothing. The answer are the x and the y values. So if you're trying to solve, you're doing the wrong thing if it says create an equation. You're coming up with what the x's and the y's are. We don't care what the x and y's are when we're creating an equation. We need to use the other information. So in that problem, it's just like this one. The information is find two numbers. So that tells you what your variables are, just two unknowns, just one number and another number. Then it tells you those two numbers add up to 12. So the two unknowns add up, well, 12 in this one. The two unknowns, if you subtract them, give you 4. Don't try to figure out what the answer is. That's the biggest mistake, and it's unfortunately a very costly mistake. I had one kid, pretty sharp kid actually, he failed the section on word problems because he kept trying to solve and put those numbers in the equation. The solutions will never be in the equation because the solutions would be the x and the y, and we've got to have x and y in there. So anyway. All right, so yeah, come ready. Did anybody actually do that? Willow, I know you were doing it. Anybody else do it? Did you do it, Jasmine? Can you pull it out real quick? Did you do it? Pull it out real quick. I should get an extra code. Willow, Jasmine, and yeah. So Willow, Linda.
Okay, bye-bye.
Bye-bye. See you tomorrow. Mm-hmm. So we get out at 43. Or I don't. Okay. Actually, let's start that at 43. So we need to start that right at, oh no, right at 11. Come on in. Oh, no, they're next to it. Oh my goodness. Let's see where we can put you. I'll be honest, I don't know. We've lost some people. I don't call everybody, and a lot of people don't show up very much anymore. Let's see. Where's my list of seats? Up here it is. Let's see what we got. See that? Oh, that's an old list there. Wow. Oh wait, no. Oh no, no, I'm sorry. So those are taken. Oh yeah, all right. So why don't you sit right here? What's your name? Say it again. Dayana. I'll let you in there. So that's your bell word. Oh, you need to grab one of these packets up here. I'll give you like 3 minutes to come up with. I mean, I don't think that'll be official bell. When the official bell rings, I'll give you 3 minutes to bell work. Actually, tell you what, we'll make it even. I'll give you till the big hand is on the 12. And I want you to actually think about this. Don't just write down some gibberish. Just guess. Yeah.
I believe it.
What?
This is probably
There is good. Their grades are done. Well, I mean, you should struggle on this one. It's gonna be pretty much the same exact. So if I do one, just make sure you do it. Almost don't have to have a fantastic understanding of it as long as you
make life so
complicated. All you have to do is change numbers. So see how you feel after today, and then we can talk. I just didn't see anything. Yeah, you watch the video, so like that. So that's what I'm saying. You're gonna have to watch the video.
I looked at her, she's like.